Hello guys, my name is Engineer Halide. We want to talk about dimension equations under dimensional analysis. Now, a dimension equation is an equation which expresses the physical quantity in terms of its dimension. It's what? It's an equation which expresses what? The physical quantity in terms of its dimension. Meaning that all physical quantities can be fully represented in dimension. And dimension can do three things. It can be used to check or to what? To find the quantity, physical quantity. It can be used to derive an equation, and it can also be used to check the validity of an equation. So we want to find the unit of quantities. We can use it, or physical quantity. We can use it to derive an equation. Then we can also use it to check the validity of an equation. But today, in the first class of this particular dimensional analysis, which is part 1, I want to talk about how to use it to find the unit of a quantity. Because this one will be another class. So how to find the units of of quantities. That means with dimension, you can find the unit of quantity. Number one, we need to know the dimension of basic quantity or basic units. Now, what is the dimension of what? Of this unit called mass, which is kilogram. The dimension of this one now is what we call what? Capital letter M. What about length, which is measured in meter? The dimension is L. What about what? Time. Time is what? It was seconds. And the dimension is capital letter T. Then we have what they call temperature. Temperature is what? In what? Kelvin. And the dimension is theta. Then we have what they call what? What they call amount of substance. Amount of substance. And the dimension, the unit is what? Mole. And the dimension is what? M-O-L. Then we have what they call what? Electric currents. Electric current. Go and watch the video. We have given all this one. The unit is what? Ampere. And the dimension is I. Now, sometimes we use A, capital letter A. It doesn't matter. But what is common is I. Then what about what? Luminous intensity. Luminous intensity. Luminous intensity is what? CD, and the dimension is what? J. Please take note of that. How many of them are 1, 2, 3, 4, 5, 6, 7 complete now? So these are the what? The dimension, the unit, and their what? Their quantity. The dimension, the unit, and their what? Their quantity. So having to understand the what? The units, the dimension, and the unit, the quantity itself, and then what we are focusing more on the dimension. Now, listen, let's go to this is fundamental quantity. Let us now go to derive. Derived what? Dimension of derived quantity. Quantities. Let's start with what? Area. What is the unit of area? Area is length times breadth, so the dimension is L squared. Let me go with volume. Volume, the unit is what? Or the formula is L times breadth, length times breadth, which is meter squared. So the unit is L squared. What about this length times breadth times height? Unit is what? Meter cube, cubion. So the dimension is L cube. What about what? Density. Density is mass over volume. What is mass, class? Mass is what? Capital letter M, while volume is what? L cube. So we can write it as what? ML minus 3. We have what they call what? Acceleration or velocity, as the case may be. What is dimension for velocity? We have displacement over time. And displacement is length. Is capital letter L, while time is capital letter T. Don't forget it's LT minus 1. The same thing with speed. Please, I cannot give you speed again. We talk about what we call acceleration. Acceleration or acceleration to gravity or deceleration have dimension of velocity over time, and that will give us what is velocity. We have already solved for it, which is L t minus 1 divided by t raised by 1. If this t raised by 1 go up, become minus 2, so I would have L t minus 2. We have what the next one is force. Force, what is the dimension for force? First of all, force is what? Please, force is mass times what? Acceleration. And what is the dimension for mass? Mass is m, acceleration is L t minus 2. Therefore, we can combine that m L t minus 2. Please, if there's anything you must remember for examination purpose, we see force, acceleration, and velocity. It applies, it found in majority, not all, of all the quantity. Now, let's talk about work. Work done. Work done is the same thing as what? Force times what? Distance. So, in terms of that, we are going to have our force is what? NL t minus 2 times distance, which is L. Don't forget distance. This one, distance. There's also length, breadth, height, width, altitude. They all belong to capital letter L. Don't forget this one can also be period. Also that. So this will now give us what? ML squared t minus 2. Don't forget. ML squared t minus 2. The same thing with work and energy. They have the same dimension. The same thing with what? Moments. And the same thing with torque. All these ones have equivalent what? Dimension. Now let's go to what? Power. Let's discuss power. Now, what is the dimension of power? Power is what? Is equal to what? Force times what? Velocity. Although power can also be what? Work over time. And you can see do it like that. What is force? ML t minus 2. Then velocity is what? LT minus 1. If you combine them, on that n, this one will give us what? L squared. While this one will give us what? T raised power minus 3. Let's talk about EMF. EMF is what? Electromotive force. Electromotive what? Force. And that will be equal to what? Power over current. That is what electromotive force will give us. Now, what is power? Power is already solved, which is what? ML squared C raised by minus 3 divided by current. Current is I. Don't forget its dimension, which will now give us what? ML squared T minus 3 and I raised by minus 1. If this I go up, it becomes minus 1. And don't forget the same thing as potential difference, PD. And it's the same thing as what? Electric potential. So if they ask what is the dimension for electric potential, all of them have the same dimension. If they ask work is same thing as rate of energy. Rate of energy is same thing as what? Work. So please take note of that. Then we have what they call latent heat. Latent heat is what? Is equal to what? Energy over what? Mass. I mean, you see, I mean, remember that heat equal to ml. Heat equals to ml. So what is energy? Energy is what? Already same thing as work is there, which is what? ML squared T minus 2 divided by mass. What is dimension for mass? Is here. This is M. This one will cancel this one. We have what? L squared T raised by minus 2. Then what about the dimension for what? Young modulus. Young modulus. I classify them. Pressure, stress. So what is dimension for young modulus? Pressure and stress. Please keep this one on your head as I will clean it. Keep it on your head because very, very important. You know that. Maybe screenshot it so that you can follow up with it. Now, what I want to do now so I can have more space to solve. Young modulus is what? Is what? Is young modulus. Young modulus is equal to what? Stress over strain. Now, please take note of that. Strain is what? Dimensionless. Dimensionless means a unitless quantity. A quantity that does not have a unit will not have a dimension. So dimension can only be assigned to the what? To a quantity that has a unit. So stress there is equal to force over what? Area. So what is our force? Go and check the part 2 video that we did. It's equals to what? Newton over what? Meter squared. That is it. Now what is force? Force dimension is what? mLT minus 2. I told you don't forget that formula. Divide by what? L squared. What do we have there? This one will cancel this one, remaining 1L. So we have mL. This one will go up as minus 1, then T minus 2. That's what we call stress. And that is the formula, the unit or dimension for what? The same thing as Young modulus. Please take note of that. Because what the strain does not have is unit. The same thing with pressure. Pressure is also the same as mL minus 1, T minus 2. What about surface tension? Surface tension has a dimension of what? Is force over what? Length. Please take note of, but force is what? mLT minus 2. I told you force appear in so many of them. Divide by length is L. So this one will cancel this one. What we have is what? MT minus 2. So now, I haven't gotten that one now. Let us see how far we can get other units, other dimension, like compressibility, like angular velocity. What is the dimension? Before we go to angular velocity, what is the dimension of moment of inertia? Moment of what? Of inertia. What is the dimension of moment of inertia? Moment of inertia is I, and it is a product of what? Mass times what? Distance squared. So now, if you want to solve that one, we are going to have it as what? L square is what? Distance square is what? L square. So that is dimension for moment of inertia. Now let's do what they call angular what? Let's do momentum first. Momentum is what? It's equal to mass times what? Velocity. I've given you all this formula. Go and play with it. If you don't remember it, there's nothing I can do about it. So this one will now be what? Mass times what? L T raised to the power minus 2. Yes, it's what? mL T minus 1. And don't be afraid, because some of you now, as I'm doing it, you are already afraid and please, it's not difficult. Just follow up, know your formula, then know your what? Your fundamental dimensions, then you go along with flow with it. What is angular what? Momentum? Angular momentum is equal to what? Moment of inertia times angular velocity. I told you before now. Mass times what? Angular what? Moment of inertia times angular velocity. What is the dimension for moment of inertia? mL square. Angular velocity is what? Rad per second. But rad does not have a unit. Rad does not have a unit. Does rad has a unit? No. So in as much rad does not have a unit, we can say that it's per second that you read the unit that we consider. Only this one per second. And what is per second? T raised to the power minus 1. Anytime you see S, it's time. So now that is what dimension of angular what? Momentum. We have what they call compressibility. Compressibility is the inverse of Young modulus, Bob modulus. Anything modulus at all in physics is the same dimension with what? Each other, whether elastic modulus, Young modulus, modulus of rigidity. So now what do? It is an inverse of what? Bob what? Modulus. So what do? What we do is that what? We now will take inverse. What is inverse of modulus now? That is what? 1 over m, look at it here, L minus 1, T minus 2. Now, if you take the inverse of that one, what will be your final answer? It becomes, if m go up according to indices, 1 over m is equal as m raised to the power minus 1. So if this one go up, it becomes what? M raised to the power minus 1. If this one go up, L raised to power minus 1 become L. Then if this one go up, become what? T raised to power 2. That will be your answer there. That is compressibility. Now, another thing again I want to talk about there is what? Capacitance of the capacitor. Capacitance of the capacitor. What is capacitance of what? Of the capacitor. Now, remember that CV equals to Q. Now, CV equals to Q. What is the dimension for charge first? Charge, which is Q. Charge equals to what? Charge is equal to what? IT. Charge equals to what? IT, which is called the formula. So which is not what? I times what? T. Now, what about potential difference, which is V? V is already what the dimension I've done it before. Go and check the dimension I did is what? ML square C minus 3 I raised to power minus 1. So that's what I did for dimension for V. So what do you now do now to calculate the what? Capacitance of the capacitor? We say CV equal to Q. So that means C will now be what? Charge over what? V. That means charge over V. Q equal to CV. I believe many of you should be familiar with this formula. I gave it before under part 1. So if you now make C the subject of formula, you are going to have that. So this one will give us IT over what? What is our this there? ML square C raised to power minus 3 I raised to power minus 1. So what do we have now? What do we have? Now let's take this M to the up now. You have M raised to power minus 1. Okay. Then let's take the L square to the up. You have what? L raised to power minus 2. Then let's take this one is 1. If you take this one up, what will it become? It becomes, if it goes up, it becomes what? T raised to power 3. T raised to power 3 plus T raised to power 1 is T raised to power what? 4. Don't forget. Because anytime it moves up, the minus will leave. So 1 plus 3 now be 4. Then if this one go up, it become what? I raised to power what? 1. So that will be your what? Dimension of capacitance of the capacitor. Don't forget to do this one and send in your comment section. Inductance of an inductor. I'll give you the hint of an inductor. And what is inductance of an inductor? Is what? Energy divided by what? Current. So if I wait for what? Like 2 seconds, or let's say I wait for what? 3 seconds, what will be your answer for energy divided by what? Current what? Square. It's current square. This current square. Remember, go and check this formula I give you. That's where you are going to get that one. At the end of the day, we are going to have inductance, which is symbol L, measured in area, and as what? Energy. Energy over what? Current square. I will stop here. Current square. So which is energy equal to what? ML square T minus 2 divided by what? Divide by what? I square. You can take it up and get your distance. Let me quickly talk about what? I've talked about surface tension, but there's one thing I need to cover about, which is gravitational constant before I leave this class. Gravitational constant. Remember I gave you what? F equal to what? G M1 M2 over R square. Remember this formula I gave you. Now, once I do this one, you can go and use all those formula, give all these derived quantity I gave you in part 2, solve all the derived, all the units here. But what we have now, this one will now become what? FR square equal to what? GMM. Then divide both sides by G, we have what? FR square divided by MM. Now, what is the unit of dimension for force? We have made G the formula. That's what we have done here. It become MLT minus 2. What is radius square? This is radius square. Distance between the two masses. R square is what? L square. Divided by what is mass? This is mass, not meter. Which is what? M times what? M. The two of them are masses. M1 and M2. So what do we have now? Now we'll cancel this one. If what? Remaining what? This times this is what? L cube T raised to power minus 2 over M. How can we write it again? You can take this one up. It becomes what? M raised to power minus 1 L cube and T raised to power minus 2. So that will be your answer. Now to end the video, go and solve question on, very important you do that. Go and solve question on impedance. Impedance have the same dimension as what? Resistance. Resistance is equals to what? Power over current square. So go and try it. Current square. You play with it. I've done power, so you know what they were. The same thing with impedance. And I think I've done the majority of things we need to do. So please try and go through there. The magnetic field, that is the last one. I need to let you what, give you hint, is what? Force divided by charge times what? Velocity. How many of you remember that F equals to QVB? Charge times velocity times magnetic field. So if you make B the subject of formula, this is what we are going to have. I've given you charge, I've solved charge. I've given you velocity, I've no force. So you can get your magnetic field dimension. Thank you very much. God bless you. I believe you enjoyed the video. Ensure you subscribe and tell other people about Engineer Haliday's channel. God bless you. Have a wonderful day.